As you have just heard, this meeting is being recorded, so please be aware of that. The recording of today will be available on ARPA-E's website. So just as an FYI, it'll also be available on the Launchpad. Keep your mics muted if you can, just to minimize any kind of background disturbance. That would be great. Semi-finalists, as you come to the point where you'll be pitching during today's workshop, please then unmute yourself. You can share your screen at that point in time, or sorry, your webcam at that time. Until then, if folks could actually turn off their webcams, that would be great, just to potentially minimize any issues that we might have with any kind of bandwidth limitation. That would be greatly appreciated. I think those are all of the public service announcements that I wanted to give out before we get started today. But before we dive in, Lane Janatowski, our director, has some opening and welcome remarks. So Lane, I turn it over to you. The floor is yours.
Okay, thank you very much. I'll be on and off in just a moment. First, I'd like to thank you very much for participating not only in this call, but in the scale-up process. When I interviewed with the Senate committee, Senator Murkowski said to me that the biggest thing that is a problem is scaling things up and avoiding the valley of death. Well, it's rather dramatic language, but I think I've learned that it's accurate. And what we're trying to do is everything we can. So if we have not done something and you bring it to our attention, if we can do it, we will do it. I'd like to thank James Saylor and Mary Yamada, and also not here in my written remarks is Kyle Nicholas, who's put a lot of time into this. Shanette Armstrong, who started this up last year just before I got here and was voted in by the Senate. So thanks to all of you who are potential partners. Thanks to all of you who have submitted as investigators, and thanks to select members of the staff. I think you all know what ARPA's mission is. It's basically to, right there in the statute, improve efficiency, reduce emissions, and reduce imports of foreign oil. We're working on them all, and we're working on them all the time, and we try to make those definitions of your project fit those things so that we can fund you. That's very much our objective. Since ARPA opened its doors in 2009, we've launched over 55 programs that encompasses 900 investigator teams. And again, you have to either own the IT or be the investigator team in order to get into this second step, if you will. These programs, I'm going to abandon what's written and let me say it out. We manage about 330 programs at any one point in time. It's worth about $1 billion in grants. Scale Up originally started, I wanted to emphasize the flexibility because it's our desire to work with you and change us to help you. We originally started with 50 million and we moved it up to 75 million. 200 teams applied to Scale Up and 32 semi-finalists were selected. Our goal is to be flexible, so we increased the amount of money we had allocated. We talked to some more people before submissions were due, and we reduced the cost share that you had to fess up to, and we eliminated any cost share in the first year, all to make it easy for people. And then, since you don't walk in another man's shoes, we found out that, well, maybe we were being too slow. So we cracked off money to develop a fast-track application so that if people were really ready right there, you wouldn't have to delay your private business or your private investigation. We would examine what you had to say and take part of that money and put it into Scale Up Fast Track. So if any of you know how the government typically operates, that's A, it's pretty fast to get a program like this up and running in a year, and then B, to make 3 major modifications in what in essence is 3 weeks. It's also pretty fast. So we're trying to do what you want. Speak up and help us bring something from concept to proof of concept, and now to fruition, if not the marketplace. All of our programs are administered, or you work with a tech-to-market team. They'll give you market insights. They'll manage your tech-to-market efforts. They'll support you with whatever skills and knowledge they have. But I think when you have commercial partners and you have financing partners, they will also be there to help you out, and they exist on the other side of the valley of death. So they'll be wanting to bring you across and should be able to give you good partnership in terms of market knowledge and money knowledge. We're trying to get real world impact here because we are charged with doing things in the real world through the use of science. So we want to take that science that we have now, you all have proof of concept, and refine it, scale it up, and put it in the real world so that the taxpayers that give you the grant money and give us our salaries to administer the grant money in those programs, so that they can get the benefit in terms of increased efficiency, less expensive power, if you will, and cleaner power. I understand that today's plan is for James and Mary to take you through a closer look at the process and the technical areas and how to get involved with your potential partners on the phone and in person. And then some semi-finalists, I understand, will give you a chance to talk to you for a few minutes about their respective technologies. We're going to do this again with another group of semi-finalists, so you don't have to sit for 6 hours or 5 hours. We've divided it up into 2-day affair based on technical interest. I quite appreciate your coming here, and I'd like to acknowledge all of you for the effort you're putting in, and I'd like to express on behalf of our employers, the U.S. taxpayers, that we look forward to your success on each and every product, so we can have a much more efficient and energy and a cleaner environment. So thank you very much, and let me turn my little podium back here to Mary and James.
Thank you, Lane. And as Lane said, yes, my name is Mary Yamada. I'm a tech to market advisor here at ARPA-E. And to just kind of give you guys a sense of our agenda for today. So we just heard from Lane Janatowski, our director here at ARPA-E. So thank you, Lane, for your opening remarks.
Thank you.
Yeah, thank you. James Zaylor, our associate director for T2M, he's actually going to be providing some closing remarks. So James, we'll tap you later in today.
I'll wave and say hi. Here I am.
Okay, hey.
Later. Yeah.
Hey, James. And then what we're going to do before we get to our pitches, I did want to just give everyone a quick SCALEUP overview. We'll walk through a quick introduction of the semi-finalists. I also want to give you guys a Launchpad tutorial. So hopefully this isn't your first time hearing this. The Launchpad is a website that we've created that has profiles for several of our semi-finalists with the SCALEUP program. So I'll walk through a little bit of that so you can see what it is and how to get there. And then we'll go into the pitches. So hopefully in about 20-30 minutes, we'll get to the pitches. And I imagine that's why a lot of you are here today. So without further delay, let's just go into a little bit of the SCALEUP overview and talk a little bit about the motivation. So Lane gave us a great setup in terms of, what is ARPA-E? Where do we sit? And I think it's kind of helpful to set the stage in terms of where SCALEUP sits. So here at ARPA-E, we use a lot of graphs, and this is no different. This is one where it's sometimes helpful to think of cost as a function of performance. So you want to see with the technology that cost decreases while performance increases. So in this rate, you want to actually see a decline. And at ARPA-E, we fund potentially disruptive technologies through our primary R&D programs here at ARPA-E. And these typically last 3 to 5 years, and the real goal of them is to get better than existing technology. So whether that means through improved efficiency, reduced emissions, greater national security, that's the gap that we're trying to close. We're trying to close that scaling gap. And when a project at ARPA-E ends, we usually are left with a bench scale prototype. So we've gone from concept and notion of a technology being potentially feasible to it actually showing some viability from that standpoint, from that prototype. But there's still a lot of challenges that need to be addressed in order for it to pass that existing technology. So that's why we've developed the SCALEUP program. So to tackle things like reliability, manufacturability, a lot of these technologies also need to provide more performance data to demonstrate to industry that these technologies really have a chance to not just be potentially disruptive, but actually succeed and surpass existing technology as being disruptive. So this is the whole premise of SCALEUP, to kind of take our technologies through the chain of commercialization. So another important thing to think about when we talk about SCALEUP is investment. And the way we generally view this is very cartoonish. So over time, ARPA-E investment, we consider ourselves to be high risk, high reward R&D investors. And so we consider ourselves to sit relatively early stage. SCALEUP certainly takes us later, which I think is an excellent, good place for us to sit. But it does represent a handoff point where we have other investors. So those from the commercial community, those from the venture capital community, we want to see that investment increasing over time. So we really see SCALEUP as a way to hand off that transition from public funding to private funding. So this is just kind of a very brief overview of the motivation. I hope it gives you guys some sense in terms of where SCALEUP sits. So to just take a quick look at the 10,000-foot view of SCALEUP in terms of a federal funding program, this is ARPA-E's first ever scaling and pre-pilot focused program at ARPA-E. It is in total a $75 million program. So this is a substantial program we have here at ARPA-E. It's very small business focused. So the majority of our semi-finalists who you'll get to hear from later, they are small businesses. And that was kind of the whole focus of this program, was to create new opportunities for startups that come out of ARPA-E. Another important thing to remember, and I will be coming back to this multiple times, is that partnering is extremely important. So whether this is with our semi-finalist potential customers, end users, suppliers, this is essential not just for their success as a startup, but also with their success with SCALEUP. Just to kind of set the stage in terms of where we are right now with this program. So the program was launched officially back in December of 2019. We recently announced semi-finalists. They were notified in early July, and we are here. This is the workshop. So this is a time that's very critical for our semi-finalists to gain those partnerships, finalize partnerships, and letters of intent for those partners actually need to be included in the full application submissions, which are due September 25th of this year. So coming up in a little over a month or so. So from there, we then will go into the finalist phase, and from there we'll go to award negotiations, which we expect to, between the finalists and award negotiations, we expect that in early next year. So that'll start in about January. So I know the moment everyone's been waiting for, our semi-finalists. I do want to give just a quick introduction to them. This is, we did select 32 semi-finalists. So 24 have agreed to make their status and project details public. So those are some of the folks that will be talking to you today. We are extremely excited about all of them. And just to give you guys a very rough sense of who these semi-finalists are, we've tried to group them in terms of applications, in terms of where their projects are focused within the SCALEUP proposal that they've submitted. So you can think of them as being kind of in the transportation space, So we have projects that are focused on things like, EV range prediction. We have battery technologies in the building and agricultural space. We have technologies that are doing crop sensoring and radiative sky cooling. In industrial, we have methane leak detection. We have low temp waste heat recovery. And in grid and renewables, we have grid edge software and lithium-ion supercells, just to name a few. And you'll get to hear from a lot of those today. To give you a sense, and I mentioned this before, but this is just some of the types of things that these projects aim to tackle. So they're looking at solving things like and improving upon technology integration. They're looking to increase building capacity. They want to validate performance and improve manufacturability and increase the reliability of their technology. The idea, as I said before, is that we want this project, this program at ARPA-E to set up substantial investment from the private sector and really launch these ideas, these companies into the commercial world. And just to quickly go over what it means to be a partner and how you can get involved with the semi-finalists, there's a number of ways, and this is just highlighting some of the very top-level ways in which that can start to form. Certainly formal partnerships, so whether that's contributing cash or in kind investment in the technology in the company, offering a demonstration site or facilities, equipment, personnel. These are all things that a formal partner can really aid the semi-finalists that will be pitching today and tomorrow. Advising partners are also extremely useful in terms of providing guidance and expertise over the course of their project to completion. So if that is something you're interested in doing, I highly recommend reaching out to folks that are pitching today and tomorrow. Equity investment is also a great way to get involved with these companies, as well as if you're interested in being a potential customer. So if the project is successful, ultimately we want these technologies to go out in the real world. So if this is something that you want to kind of know about and learn about now and potentially get involved with towards the end, that is a great way to get involved as well. And just to emphasize, these semi-finalists, they really represent the top ARPA-E technologies, companies, and teams that we have been funding for the past 10 years of our existence. So we are extremely excited and proud of our semi-finalists. And I think from here, I wanted to just quickly go into the launch pad. Let me see if I can do that live. This might be a challenge, so just bear with me for one moment as I do that. Oh. All right. So hopefully you all can see my screen. You can still see my screen. You're seeing the ARPA-E webpage. Here we've got our header of all of the things that you can learn about with ARPA-E, and we've got the SCALEUP Launchpad here. If you click that, that should bring you right to the site. And here is where you can find more information on all of the semi-finalists that are presenting today and the ones that are presenting tomorrow. We've got information on the workshop, so once we've got the recordings up, they will be here. Please feel free to revisit them if there's anything you missed or if you weren't able to make one day or the other. And then here we have where you can learn more about our semi-finalists. Here you can click on their profiles and you can learn more about who they are as a company, who they are as a technology. There's also contact information. And a lot of them have provided additional longer form pitch videos than what you'll be hearing today. So you can learn even more about each of these teams. So I just wanted to briefly show everyone what the Launchpad is. You can get to it from the ARPA-E website. So I would definitely encourage anyone on the line today to, if they want more information, to explore that. So without further ado, I will go back to the presentation. I'm tempting fate by doing all of this, I know. Okay. Aha, And I'm back. Excellent. So the Launchpad is live now, as I said. Please do take a look. Highly encourage that. And without further ado, this is the point where we get to our pitches. So this is kind of just the slot of who we have today. We're going to go in alphabetical order. And then just to highlight, again, this is part 1 of 2. So tomorrow we will be featuring several more of our semi-finalists. So I would highly recommend if you're able to tune into tomorrow as well. So without further ado, I think first on our list is Advanced Power Electronics. Dr. John Elms, who is the president, will be pitching for them today. So John, whenever you're ready, the floor is yours.
Hi, Mary. Thank you. Thank you. Can you hear me okay?
I can hear you just fine, yes.
Okay, great. Thanks. Hi, I'm John Elms from the Advanced Power Electronics Corporation, also known as APCOR. We're partnered with the Illinois Institute of Technology. Our proposed scale-up effort we've identified as the Smart Plug 2.0. The key concept is that the power grid of the future will require improved safety, control, automation, and data analytics, with a strong requirement for interoperability with smart grid and smart home applications. The core technology of the Smart Plug 2.0 is a solid-state circuit breaker and the accompanying control and analysis capabilities, which will allow our solution to be the first NEC and UL compliant drop-in solid-state circuit breaker solution. The solution offers instantaneous, programmable, and adaptive fault identification and mitigation. So that is in orders of magnitude faster, more robust, and offers comprehensive protection compared to traditional circuit breakers that you're familiar with. Additionally, the technology offers smart home and smart grid API interactive load monitoring, diagnostics, and control. And the platform also allows for higher level data analytics, which can be used for efficiency improvements and utility side power quality improvement. Effectively, we're bringing together the ability to offer the necessary protections of a circuit breaker, bringing that to a much higher level, and then on top of that, allowing for data analytics, which can be used as a platform for many other very critical smart home, future business, power grid type solutions. So it's interoperability is the key, and we're developing a hardware that will allow to do that with the very important goal of adding much higher levels of safety on top of that, just by the virtue of being a solid-state circuit breaker. Our commercialization strategy is multi-point, where we want to have drop-in replacement circuit breakers, which are fully NEC and UL compliant, which would be perfect for retrofit and new construction. And that offers full protection within a building or a structure. We want to offer smart power receptacles, which have improved granularity for analytics and control that can be used for one or maybe only a few loads, as well as inline devices which can be moved and easily installed for the most flexibility. Our commercialization strategy, we're targeting sales of hardware and software to OEM customers, as well as licensing of IP for integration into third-party devices, systems, and solutions. Thank you for your time. If you're interested for more information, please contact me at jelms@appcor.com, which can also be found on the ARPA-E Launchpad website. Thank you.
Thank you, John. All right. Moving forward. All right, next we have Dr. Peter Roos, President and CEO of Bridger Photonics. Peter, are you with us?
I am. That is not our slide.
Is this your slide?
It is. There we go.
Okay. All right, whenever you're ready.
All right, thanks. Hi, my name is Pete Roos. I'm the President and CEO of Bridger Photonics in Bowesville, Montana. Over the past 5 years, and with the support of the ARPA-E Monitor program, we've developed gas mapping LiDAR, which is the next generation in methane leak detection and quantification. Methane, as we know, is a potent greenhouse gas, and the oil and gas industry is under tremendous pressure right now to reduce emissions. Industry desperately needs a solution that will disrupt the current process of visiting each and every site on foot and scanning each and every piece of equipment by hand to uncover methane leaks for repair. With gas mapping LiDAR, we attach a proprietary laser-based remote sensor to the underside of an aircraft and scan oil and gas infrastructure for methane leaks throughout the entire natural gas value chain, from production to transmission to distribution. We hand our clients a sensitive answer key that pinpoints and quantifies the leak rate of every important emission in their infrastructure. With the plume imagery, you see it draws our attention, but the greatest value we offer lies in all those sites and all those pieces of equipment that don't have leaks. We have such high sensitivity and localization capabilities from the air that we eliminate our clients' need to search for leaks on the ground. This typically allows them to skip the costs and hazards of visiting 60 to 90% of their sites with ground crews. And when they do need to visit a site, our data products direct them straight to the leaking equipment. Finally, our analytics enable industry-leading quantification so our clients can prioritize their leak repairs and accurately track emissions reduction. These capabilities are enabled by a compact but powerful semiconductor optical amplifier that we co-developed with MIT Lincoln Labs and which we now exclusively license. With enough light from this amplifier to generate rich plume imagery, we've created proprietary advanced analytics to distill all that complex information into simple, actionable data products for our clients. All told, we now have 20 patents and patents pending, and this technology was just awarded an R&D 100 award for 2019, which annually recognizes the top 100 innovations worldwide. Our gas mapping LiDAR revenues more than doubled in each quarter of 2019, and we reached profitability more than a year and a half ahead of schedule in Q1 of 2020. Over the next 18 to 24 months, we're seeking to build strong relationships with strategic Series B investment partners that will tangibly support us in scaling our operations globally into this multi-billion-dollar market. Thank you very much.
Thank you, Pete. All right. All right. Next, we have Christina Lamp-Unarud with Cadenza Innovation. Christina, are you here? Christina, I can't hear you yet. Christina, still not hearing you. No, I saw you earlier. Let's see. Do some. Looking here. Okay. So what we'll do is I'm going to skip over Cadenza for now, unless is that Christina?
That was Rich Maisel. Next.
Oh, okay.
Yeah. Yes.
All right. So we'll,
Can you hear me now?
Oh, yes. Hi,
Okay.
Christina. I can
Wonderful.
hear you.
Okay,
Excellent.
great. Thank you so much.
No problem. All right. Let me get you to your slide. And whenever you're ready.
I'm ready. Thank you so much for the opportunity, and thanks to the ARPA-E DOE family. We are really excited to be part of the semi-finalist lineup, and we are bringing to market a lithium-ion technology that uses 20 years of experience, everything from organizing atoms into cathodes and anodes and electrolytes, into the opportunity of using all the experience into a new architecture, a cell, called the supercell. That's what we worked with ARPA-E on in the early years, 2012 through 18. And we now have reached the stage where these supercells are demonstrated into cars, into grid, and is going into specialty market opportunities. What you see on the picture here is in the center, the supercell, an exploded view. Not a good word for the battery industry, but a great word for just looking at CAD drawings and understanding what's inside. So using a chemistry agnostic platform where you can take the knowledge and global supply chains and bring them back home. Put together the normal coatings, advanced coatings in the future, and prop them right into the supercell, where we have given cost the same weight at the design table as we did with performance. And king in this solution is the total safety and reliability. With that, we've put basically 20 years of experience on the inside of the supercell. And that is now a Lego block of energy that you can package effortlessly into big systems. So what you see just to the left of the supercell is one of those illustrations. That's a module that is going into what you then see on the very left, a rack prepared for grid installations, which is our proposal in this scale-up opportunity. This rack has basically BMS at the top and lots of supercells. And we have already launched a program of validation with NYPA and ABB under NYSERDA, the state of New York. And this system and these cells are basically going through some of the toughest requirements for in and outdoor installations. The system is already certified for the demonstration, which is actually going to happen at NYPA headquarters. And with that, we got a lot of attention on our hands. We have in this proposal a lot of support from the market, both in the New York City market, which is very, very difficult, the greater U.S. market, and abroad. We have a chance with this opportunity to scale up U.S. manufacturing with a leading technology on cost, reliability, and safety.
All right. Thank you very much, Christina.
Thank you.
All right, next we have Dr. Rich Mazel, CEO of Dioxide Materials. Rich, whenever you're ready.
Why don't you go? Yep, I'm sorry to put the eye chart here. I just realized that everybody else doesn't like your charts. But I'm Rich Mazel, CEO of Dioxide Materials, and today I'm looking to meet companies that are interested in reducing their carbon footprint. You know who you are. You need to reduce your carbon footprint. We've got a solution for you. Our solution is to convert CO2 into valuable products and use those product revenues to pay for everything and even make a profit. We are planning to offer an integrated solution. If you have a use, we make CO as an intermediate. If you can use it, wonderful. We'll work with you. But even if you can't, we have the whole process. Take in CO2, take in renewable energy, put out fuels and chemicals, and it pays for the whole thing. Argonne National Labs actually worked out did an LCA for our projects and found that we could make, say, ethanol for only 2 milligrams of CO2 emitted per megajoule, compared to, say, fuel ethanol, which is 60 grams of CO2 per megajoule. Sorry, I'm not real good at this end. We're doing this because we have a couple things that are real advantages. One advantage is that we've made the first alkaline exchange membranes that are stable for 12,000 hours. We've actually tested for 12,000 hours. How many other companies here have done that? And then we've got great catalysts. And these things really work. We've already sold 200 of these units in the field. You just don't sell 200 units unless the stuff really works. You can ask, my fortune have gone up already by now. Okay, you can ask how we compete to the competition. Well, there's a company named Rex Research that's been looking at this whole area to just find out how things work. If you look at Let's Research, what they did is they plotted all the companies. You see Opus 12 is there, we're there. What you see is that at least this one external company thinks that our technology is the best, but it also says that we need to develop the business and scale and all the other things that we need to do. The object of the SCALEUP program is to scale the electrolyzers to an industrial scale and make everything in roll-to-roll equipment. That means you do it in a commercial scale and you have to get rid of the defects. The defects are the biggest problem that happens when you do the systems. Sorry, I'm going too fast here. We're now looking for partners. We're looking for companies that want to really do something that can reduce the carbon footprint. If you need to reduce your carbon footprint, you need to contact us. We can do it. And of course, we need in-kind contributions. I have my contact number on the slide, Rich Maisel at DocksiteMaterials.com. You can also look on the launch pad. If you have problems with CO2 and have to meet your milestones, we can help.
Thank you, Rich. So next, we have Donna McConey, CTO of Imagen Energy. Donna?
Yes, thank you, Mary. Yep.
Right.
Can you hear me?
I can hear you whenever you're ready.
Great, thanks. So today we'd like to talk to you about our project that we're working on for during SCALEUP. We have developed this technology during a circuit program, which has a very aggressive target, both in volume and weight density. And we were able to develop what we call IM1500. It's a motor converter, motor drive for high-speed permanent magnet machine. Picture on the left, you'll see our IM1500 compared to two other leading companies. And we're able to push the operating frequency, operating voltage, and drive efficiency very high. And in doing so, we were able to attract a potential customer that's actually going to be part of our SCALEUP project, APG Neuro. They're involved in developing a turbo blower for wastewater treatment. And their main interest is in the efficiency gain that we can make with this drive, but also the new class of motor that could be developed based on these type of performance, high performance drive. So you could see the competitor on the picked graph on the right, where peak efficiency that they can get today is a 96%. We're hovering around 99 and 98 across the 40% to the full load. So these are systems that are developed in the 1980s and right now aging, as well as very inefficient because they tend to run 100% of the time. And there are significant dollar savings. So we're looking for partners to help us develop 0.5 to 1.5 megawatt motors for the water waste treatment application, but also beyond the water waste treatment, because these are compact motor and drive that could be used in aerospace, propulsion, and traction. With the APG Neuro alone, we should be able to sell around 100 units for new and 100 units for upgrade that can represent up to 50 million a year. And we're looking for a commercial partner to help us deliver to this one customer, but also these other new applications and opportunities that comes with a compact motor drive. Our contact information is also included in the launch pad. Thanks so much.
Thank you, Danya. So next, we have Michael Cushman, who's the president and CEO of Mantel Technologies. Mike, are you with us?
Sure. You got me?
I got you. I can hear you whenever you're ready.
All right. Thanks, Mary. Appreciate it. Yeah, so I'm Mike Cushman, president and CEO of Mantel Technologies, and also our subsidiary company, Cooling, that we set up to actually commercialize the technology that we're exploring here. So I get the opportunity to give you guys a glimpse into some of the exciting work we're proposing to perform under the SCALEUP program. While it doesn't receive the same level of attention as other alternative energy solutions, resource recovery, in our opinion, will be critical to a sustainable, resilient, and efficient future. So in exploring this paradigm, our team determined that a sizable untapped opportunity exists in recovery of low-temperature heat and subsequent conversion to cooling. By addressing the size and economic downsides of incumbent solutions, we're in the position to grow the U.S. heat-to-cooling market and also tap into the multi-billion-dollar global cooling market. Our project's going to involve the full-scale demonstration of a turbo compression cooling system, or TCCS, at an industrial partners facility. So we've stripped away our demonstration site. It's a very large heat generator with a high demand for refrigeration on site. As seen in the top left of this slide, TCCS is a compact, low-cost approach to capturing low-temperature waste heat and converting it into cooling. The technology relies upon a combination of low-cost, compact, commercial off-the-shelf equipment with specially designed turbo machinery to effectively and efficiently capture low-temperature waste heat, typically exhausted to the environment. The footprint of the technology represents an unmatched payback potential. For example, even at municipalities where electricity is cheap, such as Texas, where we're looking at prices on average of 8.5 cents per kilowatt hour, the TCCS would approach a payback period of around 2 years, while competitive solutions are exceeding 10. We're also actually actively engaged with the Navy developing a shipboard version of this system. With respect to our proposed SCALEUP program, we're going to be provided with a means to demonstrate the potential of the technology in an industrial setting, and we're going to do so at a 1.5 megawatt cooling demonstration. Year one is going to be focused really around commercial product design, demonstration site integration plan development, and kind of broad customer engagement and business planning. In year two, we're going to construct a full-scale prototype, do shakedown testing, and then install at the demo site where we'll perform some initial validation of the product. In the third year, the commercial unit design will be finalized based on our demo outcomes. We'll also aim to secure our first commercial orders and the next stage of investment prior to the end of the 3-year program. So if you're interested in partnering us, we'd love to hear from you. My contact information is on the slide. Thanks a lot.
Thank you, Mike. Next, we have Pablo Ruiz, CEO and CTO of the New Grid, Inc. Pablo, I see you. Can I hear you?
Yes, thank you, Mary. Can you hear me?
I can. All right, let me get to your slide. And ready whenever you are.
Thank you, Mary. Good afternoon, everyone. It's a pleasure to be here and tell you a little bit about New Grid. New Grid's transmission topology optimization software technology is like a waste search engine for the transmission grid. Whenever you're driving and you face congestion, you pull your Waze or your favorite GPS app and look for alternative routes around the congestion bottleneck to save some time. Similarly, whenever there is congestion on the transmission grid, the New Grid software finds the best reconfiguration options to route flow around congested elements, relying on the vast majority of the transmission lines that have spare capacity. These reconfigurations increase the utilization of the grid, and as a result, they relieve congestion, improve reliability, and also enhance the grid resilience. This is a software technology that relies on hardware. The reconfigurations are implemented by switching circuit breakers on or off, also using existing infrastructure for communications and control. On this slide, you can see a condition of the wholesale power market in the Great Plains, that's the SDP market, before and after application of the technology. On the left-hand side, without the reconfigurations, there were wind curtailments. That means wasted production of wind that was otherwise available due to congestion. The New Grid software very quickly found reconfigurations that rerouted enough flow around that bottleneck to enable all of the wind production in the area to reach the market. Also, in the historical case, there were transmission breaches. There was one transmission breach, which posed a reliability concern. Again, the reconfiguration found by New Grid rerouted enough flow around it to provide full relief of that reliability concern. It was indeed implemented by the system operator. The new grid value proposition benefits both the market participants and society as a whole. The large-scale adoption of the technology will provide up to $1 billion in annual congestion cost savings across the country, and that's under historical conditions, potentially much larger in the future. That would boost the profitability of generation companies that own clean and efficient assets, and at the same time lowering prices for consumers. It will also instantly enhance the value of all transmission assets, both existing and new, because the technology enables the grid to transfer more power, about 10%, based on our studies, without requiring any additional hardware. And as we saw in the case study, enabling higher penetrations of viable renewable generation. We are seeking for a large-scale application of the technology as part of the ARPA-E SCALEUP program. Please contact us through our website shown on the slide. We look forward to speaking with you. Thank you.
Thank you, Pablo. I'm getting a little bit of background noise. Just a reminder to folks, if you're not up or if you're not next, just please mute your lines. So with that, next we have Rita Hansen with Onboard Dynamics.
Hi, Mary. Can you hear me?
I can.
There's quite a bit of background. Yeah, there's some background noise.
There is. Yeah, let me.
Who's in charge of everything?
Look at you. You're looking fit, man. Still.
Send your text.
Hey, so Kyle.
Yeah, no, I saw it. Yeah.
Kyle, you are unmuted.
I
Kyle. Kyle Nicholas, you are unmuted. Okay. I think I can mute him.
You have control, Mary.
I have control. There's so many people logged on, though. I'm trying to get to okay. Come on.
What are you doing?
Okay.
Also, where'd you?
All right. Ha. So I win. So sorry about that, Rita.
No worries, Mary. Fortunately, we had a trial run last week, right?
Exactly. For these exact emergencies. Yes. All right. Well, Rita.
Can you put up my slide? Yeah.
I can.
Thank you.
Whenever you're ready.
Awesome. Well, thanks, Mary. So she didn't get all the way through the intro. So my name is Rita Hansen. I'm the CEO and co-founder of Onboard Dynamics, and we're based here in Bend, Oregon. So today our company is helping customers reduce emissions and save fueling costs, all at a scale that meets their previously underserved applications. So we also were initially funded by ARPA-E to address the critical lack of available and affordable natural gas refueling infrastructure here in the U.S. Simply put, our innovative technology puts the C in CNG, compressed natural gas, whether it's from a geologic or a renewable source. So our first product to market, shown here on the left of the slide, is the GoFlow CNG 80 compressor. The system runs on natural gas to compress natural gas, no diesel or electricity required, and it can be tapped into any low-pressure natural gas supply point. Our newest product is on the right of that compressor, and it's the GoFill Refueler, launched last week. And it's a dispensing system for simultaneous refueling up to 4 vehicles. We did this in partnership with one of our great customers here in the Pacific Northwest. Packaged together, they are a complete, self-contained natural gas refueling station, mobile, scalable, and easily redeployed. And we generated over $1.6 million in sales since our product launch in late 2018 in fleet refueling and natural gas utility operations. Our intent with the ARPA-E SCALEUP opportunity is to expand that core compression technology to include methane cleanup and conditioning on the front end. This will enable the capture and use of stranded gas and biogas generated from agricultural opportunities at sites that are deemed too small based on today's technologies and economics. So the cleaning, conditioning, and compressing package, which is shown on the right, will meet a scale of 100 to 150 MCF per day. It will be electric and diesel free. It will be mobile. It will produce fuel-grade methane that can be used locally for refueling or injected into a pipeline or loaded into a tube trailer, and it will be cost-effective. We are seeking commercial partners from the oil and gas and renewable natural gas sectors that can bring industry expertise and or potential demonstration sites and or economic support. And the ideal financial partner is a corporate strategic or a party who's interested in reducing emissions and participating in our growing company. So I just want to say we have the team, we have the current technology to compress methane without external electrical power at an underserved scale, but we would like you to engage with us for our next success, expanding to address natural gas and renewable natural gas opportunities. Look for us on the Launchpad website. Please feel free to reach out to me via email or phone. Thank you again to ARPA-E for all the support.
Thank you, Rita. All right, great. Okay, next we have Natasha Cave, co-founder and chief scientific officer of Opus 12. Natasha, are you with us?
I'm here. Thank you, Mary.
Hey, all right, let me get to your slide, and whenever you're ready.
Great, yes. So at Opus 12, we would be leveraging the SCALEUP funds to build the world's first megawatt-size PEM CO2 electrolyzer. And building this megawatt-size system will enable us to take CO2 emissions from a point source or couple with a technology that can take CO2 out of the air and use electricity and metal catalysts to convert that CO2 into fuels and products. Now, by going to the megawatt scale, we can drive down the cost quite significantly. And we do that by, one, creating this larger power-dense electrode, so we can convert more CO2 per unit surface area of this power-dense electrode, which is our core technology. We also can leverage the manufacturing partnership that we've had for several years with a US-based manufacturer who's already built these reactors at these larger scales, analogous reactors at larger scales, and we would be a drop-in component repurposing their existing line of products and basically doubling the amount of output they can produce in terms of products within the US. Now, within SCALEUP, we've already gotten the signed commitment letter from one of the largest utilities in the US to support us doing our SCALEUP work. And so we're looking forward to having that cost share from a utility that's interested in not only supporting our work, but also helping us has identified a site for us to go and do our demonstration in year 3 of the project. We have our US manufacturer that I mentioned earlier that has already scaled up analogous electrochemical systems and is working closely with us to do the same for this particular system. And then within our team internally, we have decades of experience productizing electrochemical technologies. And so we have the ability to both characterize our system and understand it as we develop it, and so that can allow us to just bring down costs and optimize as we build up. Now, after SCALEUP, you can imagine us leveraging this system, this shipping container size system, as you see down at the bottom of the slide, where we can attract investors and start to deploy it both in the US and worldwide. We've gotten interest from multiple parties. One example is with the Air Force. They're interested in making jet fuel anywhere in the world, which our system can enable, and we can reduce the casualties in fuel convoys within the US military. We've also gotten interest from many companies who are not only interested in reducing their CO2 emissions, but actually want the products that we can make. And we, in our initial ARPA-E grant, created a first initial system and made products out of CO2, which we then could show to these companies that we can make. So join forces with us if you're interested in supporting large-scale CO2 electrolyzer and large-scale CO2 emissions conversion. And please contact me at the information below.
Thanks, Natasha. Okay, so next we have Paul Hines, co-founder and CEO of Packetized Energy. Paul, are you here?
I am here. Can you hear me?
I can hear you. Let me get to your slide. All right, so whenever you're ready.
Great. Hi, I'm Paul Hines. I'm CEO and co-founder of Packetized Energy, and we are working to enable the future of clean energy through flexible, resilient energy systems with our ARPA-E funded technology, Packetized Energy Management. Today, as you all know, wind and solar are the fastest growing sources of electricity worldwide. Well, this is really great for the climate. It's actually a serious challenge for the grid. In order to address this challenge, we need to make the grid more flexible. Everybody agrees on this. We've heard about lots of technologies, batteries, and other things. The question is, how do we do it? We can build lots of batteries. Batteries are pretty expensive still. We can do conventional demand response, which provides us some amount of flexibility. But just shutting things down during peak periods doesn't really solve the problem of variable renewable wind and solar. At Packetized, we've developed a new approach to demand-side flexibility that uses algorithms that make this phone call work on the internet to scalably coordinate the behavior of millions of behind-the-meter energy devices to provide a wide range of different types of grid services that go way beyond traditional demand response. And so we're able to do peak load reduction that lots of people are able to do. But in addition to that, we do real-time load shaping for energy markets to reduce energy costs. We're able to do real-time distribution system constraint management. We're able to do ancillary services that get sold into the wholesale market. And we're able to do resilience. We'll be demonstrating these things through our products. The challenge, though, is that demonstrating that coordinating all of these DERs is really only half of the battle. The other half is to demonstrate that behind-the-meter flexibility is cost-effective with traditional sources of capacity like energy storage and peaking power plants. So this project will demonstrate a scalable and cost-effective approach to deploying this new load. We'll be using our innovative mobile technology, our phone app, which uses concepts that enable two-sided platforms like eBay and Airbnb and Lyft to rapidly scale to serve thousands of people. In this project, we'll demonstrate how to dramatically improve the overall customer experience for people who participate in these programs, making it really easy for customers to join these programs and making it easy for them to manage their devices once they join the program. Through our innovative technology, we're going to demonstrate that behind-the-meter flexibility can be deployed at about half the cost of conventional battery storage capacity. So the graph here shows NREL projections of where battery storage technology can go, and our expectations based on our estimates of what we can do with behind-the-meter flexibility. We expect that we can get well under half the cost of those traditional sources. And so we would like to invite people to join us. We've got an amazing group of customers who will be doing this in California with community choice aggregators. We're looking for investors and strategic partners who'd like to join our team. Thank you.
Thanks, Paul. Okay. So next we have Steve Visco, CEO and CTO of PolyPlus. Steve, are you here?
I am.
Excellent. I can hear you.
And I'll start my video.
Yeah.
All right. Great. Thanks. It's a pleasure to be able to talk to you about the technology in development at PolyPlus Battery Company. PolyPlus has been around for a while. We were founded in 1991. It's actually the same year that lithium-ion was launched commercially. And since that time, lithium-ion has in some ways changed the world. It has grown tremendously. It's obviously addressing a large market, but it's also a commodity, and the margins are razor thin. So that's a difficult market to enter. PolyPlus has never been in the commodity business. We develop step change technologies. In 2011, one of our ARPA-E funded technologies was recognized by Time Magazine as one of the 50 best inventions of 2011. We've sold actually a few $1 million worth of those batteries, and we're actually in the process of setting up large-scale manufacturing for that technology. That also went on to win a Gold Edison Award in 2012. But today, actually, I want to focus on a really radically different technology that addresses the entire rechargeable battery field, which is based on the use of ultra-thin glass. So in the upper left-hand corner, you see a spiral glass structure. So that represents the technology we're developing, which is 20 micron thin glass. It basically replaces the separator in, say, a lithium-ion battery. But more importantly, it allows us to introduce lithium metal in a way where the lithium metal can be cycled reversibly. Now, why lithium? Everybody knows that lithium, in a sense, is the end game, at least for the anode in rechargeable lithium technologies. But it has a long, troubled history. Lithium doesn't tend to cycle well, and it can be, in fact, a safety problem. The use of glass and continuous glass is the only way you can get lithium to cycle reversibly without forming dendrites, and that allows for a step change in energy density. So if you look at the chart to the right, this is our basic structure where we combine lithium on glass with a conventional cathode. It's about a doubling in energy density. So this would allow us to enter the market where premium margins are possible, and then as we scale, of course, we'll reduce cost. Now, importantly, we have a very large patent portfolio wrapped around all of this. As a whole, PolyPlus has close to 230 patents, 6 granted on the glass technology and 36 pending. We work with some of the largest glass companies in the world on this technology. PolyPlus makes its own glass. We also work with Schott, a large German glass company, and Umicore, which not only makes glass, but is probably the largest producer of cathode material for the lithium-ion industry. So they're working with us to commercialize the technology. We also are working with both Schlumberger, which is an offshore oil and gas company, or deep oil drilling company, and SK Innovation, one of the largest producers of electric vehicle batteries in the world. So we have strategic investors and partners now. We are certainly interested in bringing in additional equity investors and possibly strategic investors if you're interested in the technology. So if that's the case, we'd be more than happy to talk with you and kind of walk you through all the details of the technology. And that's PolyPlus.
Thank you, Steve. All right, and I think that is the last of our pitches for today. Thank you to all of the semifinalists who presented today. I do want to emphasize, if you are interested, if any of what was said today piqued your interest, to please reach out to each of our semifinalists that presented today through the Launchpad. As I said before, contact information for all of the teams is available on that site. You'll also be able to find out more information on the semifinalists as well. Apologies, this website, this first web address for the Launchpad is incorrect. It should also say SCALEUP Launchpad. Apologies, but if you go to the ARPA-E webpage, the homepage for ARPA-E, you will be able to easily link there. Connect with our semifinalists, and please, contact us if you'd like to learn more. I know, James, you wanted to give some closing remarks. Anything else?
Mary?
I did it. I'm sorry. I'm
kidding. I was going to thank everyone for joining, right? So this was, I think, a great collection of pitches. Just wanted to emphasize to the folks on the line, we'll be here tomorrow, same bat time, same bat channel. We'll be talking to 12 more applicants tomorrow that you'll be able to take a look at. A couple of things to emphasize: this is all about creating partnerships for these applicants so that they can succeed in the marketplace. That's where ARPA-E's mission is achieved. So I would encourage you, as Mary said, to reach out to the teams that you saw today that might be interesting to you. Connect with them. You have about a month and a half before the full applications from these semifinalists are due. So the clock is ticking, and it's your opportunity to provide a letter of interest, but also influence what they're doing. Ultimately, we want these projects, these full applications, to be ambitious and impactful and get these technologies to a point where the reliability, the scalability, the value is demonstrated so that you as partners can acquire the technology, can purchase the technology, can invest in the technology as the next step in the development of all of these projects. I guess one other thing to emphasize, I apologize to everyone online for COVID being a thing and for this not being much more interactive. And so Mary already mentioned it, but please do feel free to reach out to anybody at ARPA-E to discuss further SCALEUP, to provide your thoughts on SCALEUP and your reaction to what you've seen today. And I think also to just to just inform us what's of interest to you in general. And I think that Lane alluded to this earlier. We're always reaching out to our larger stakeholder community in both industry and investors to understand what motivates you, what's exciting to you. We are happy to have those conversations, so please do reach out. And with that said, I'll thank Mary for an awesome job and the rest of the ARPA-E team. And I guess I'll let you guys go, and we'll do this again tomorrow.
Yeah, same time, same place.
That's right. All right.
Different link. Use a different link.
Yeah, that is true.
Yeah.
All right. Thank you.
Thank
Bye-bye.
you, everyone. Bye.